In this section, we'll review graphing lines. So what we have to remember about graphing lines is that you can use a table of values. There are lots of other methods for graphing lines, but if you can do some computations fairly quickly, you can do it with a table of values, and that way you don't have to memorize anything. All we need to do is solve the equation for y. So in A, I'm going to subtract 3x from both sides of the equation, and then divide through by -2, so that's going to give me positive 3/2 x minus 6 when I divide by -2. Just be careful with your signs. And now we need to pick some values. And I'm going to pick some x values. Let me actually erase that line there, and we'll do this so we have a little bit more room for computations. And we need to pick some x values that are multiples of 2, since in our equation we are going to multiply them times 3/2. So anything that's being multiplied by a fraction with a denominator of 2, it's more convenient if you can pick multiples of 2. So let's use 0, 2, 4, and 6. So if x is equal to 0, 3/2 times 0 is 0, minus 6 is -6. And so I'm going to graph a point 0, -6. That's the y-intercept, and you may remember the y equals mx plus b form. When x is 2, 3/2 times 2 is 3, minus 6 is -3. So 2, -3. When x is 4, 3/2 times 4 is 3 times 2, or 6, minus 6 is equal to 0. So we have the point 4, 0. And by this point, you notice there's a pattern. We can go ahead and do 6 as well. 6 times 3/2 is 9, minus 6 is equal to 3. And so we have the point 6, 3. And you notice that our slope is positive 3 over 2. So we can continue to graph points. And it's important that you graph the points, all of the points that have integer coordinates. So we want to include those dots on the integer coordinates all the way to the end of the graph and then connect. We want our graph to be as accurate as possible. All right, in example 1b, we have the equation x equals -2. This is the easiest one to do by a table of values, because when you create the table of values here, you just put -2 in the column for x, because x is always equal to -2, and then put whatever you want in the y column. 0, 1, and 2 are my favorite numbers. So x is -2, y is 0, -2, 1, -2, 2, and by this point we don't need to make a table with the rest of the values. You can realize that this is a vertical line, and again, I'm going to include all of the points with integer coordinates all the way to the end of the grid and then connect them. So those points need to be explicitly plotted. And last one, x plus 3y is equal to -6. So first thing we're going to do is we're going to solve this for y. So I'm going to subtract x from both sides and then divide by positive 3, so that'll give us -1/3 x minus 2. And so if we multiply by 1/3, we're going to need multiples of 3 for the x values. So if x is 0, 3, 6, that should give us enough points to get an idea about what this looks like. -1/3 times 0 is 0, 0 minus 2 is -2, so I've got the point 0, -2. And then -1/3 times 3 is -1, minus 2 is -3. So 3, -3. And then if we plug in 6, -1/3 times 6 is -2, minus 2 is -4. So 6, -4, and by there you can see that we have a slope of -1/3. So we want to continue that, plotting all of the integer coordinates all the way to the end of the grid and then connecting with a line. You can use a straight edge or not, as long as it's fairly good. All right, and that's pretty much it for lines. You don't need to know all of the forms in order to graph them. All you need to know how to do is to create a table of values.